working with. We will use all the factors in the least common multiple and attach to each factor the highest exponent that appeared on each factor. The highest exponent on a 2, the highest exponent on a 3, the highest exponent on a 4, and so on. So for example, if we were asked to find the least common multiple of 24 and 36, we would start by finding the prime factorization of both 24 and 36. 24 is divisible by 2 12 times, which is divisible by 2 6 times, which is divisible by 2 3 times, which is divisible by 3 once. We find the prime factorization then is 2 to the third power times 3. We then can find the prime factorization of the other number, the 36, which is divisible by 2 18 times, which is divisible by 2 9 times, which is divisible by 3 3 times, and divisible by 3 once. Using the factors we just found, the prime factorization is 2 squared times 3 squared. We now can identify the least common multiple of both numbers by using all the factors that showed up. As we were dividing, the factors that showed up were 2's and 3's. We will then attach to the 2 the highest exponent that shows up on a 2. We have 2 cubed and 2 squared. The highest exponent is a 3. And so that's the exponent we attach. We then can look at the 3's, and the highest exponent we see on a 3 is squared, and so we stick that on the 3. The least common multiple, then, of 24 and 36 is whatever 2 cubed times 3 squared is. Order of operation asks us to do the exponents first. 2 cubed is 8, 3 squared is 9, and 8 times 9 is 72. And we now have our least common multiple of 24 and 36. The nice part about the prime factorization method is it works just as well when we have 3 numbers. Let's take a look at this one. Finding the prime factorization of 12, divisible by 2 6 times, divisible by 2 3 times, divisible by 3 once. So it is 2 squared times 3. Finding the prime factorization of 54, it's divisible by 2 27 times, which is divisible by 3 9 times, which is divisible by 3 3 times, and divisible by 3 once. The prime factorization of 54 is 2 times 3 cubed. Doing the 72 also, divisible by 2 36 times, divisible by 2 18 times, divisible by 2 9 times, divisible by 3 3 times, divisible by 3 once. The prime factorization of 72 is 2 to the third power times 3 squared. Now that we have those prime factorizations, we can identify the least common multiple by taking all factors with highest exponents. As we were dividing, the factors we ended up with were 2's and 3's. We will then attach to the 2 and 3 the highest exponent that shows up on each. Looking at our 2's, the highest exponent is 3, so we have 2 cubed. Looking at our 3's, the highest exponent there is cubed. So we will attach a cubed onto the 3. The least common multiple, then, is whatever 2 cubed times 3 cubed is. 2 cubed is 8. 3 cubed is 27. Multiplying 8 times 27, then, 8 times 7 is 56. 16 and 5 is 21. So 216 is our least common multiple. We found that by finding the prime factorizations, then using all factors with highest exponents.